This is Advanced Engineering Mathematics by Peter B. O'Neill. This PDF is for 7th edition. Actually, I prefer either 5th edition or 4th edition, but I don't have the PDF books for either 5th or 4th edition. I will use 7th edition when I discuss engineering mathematics. In near future, I will discuss complex functions. Starting with chapter 19, we will learn about complex numbers. Also, in this book, Advanced Engineering Mathematics by Erwin Krejci, this is 10th edition PDF. In this book, in chapter 13, complex numbers and functions, we will learn how to do complex differentiation in near future. I will discuss how to use complex numbers for CUDA kernel. Hi everyone, my name is Thomas Kim. Today is May 12, 2022. This is my 1/10th episode for CUDA SQL OpenGL, OpenCL, MFC tutorial series. This is also 4th episode for numerical analysis. In this episode, we will learn how to use thrust complex number for CUDA Toolkit. If you haven't watched my previous video, episode 109, please double-click this link. If you haven't watched my previous videos listed here, it might be difficult to follow my current and future sessions. Show more in the download source code section. Please click this link to download the source code from our previous episode. Unzip it, rename 110 complex numbers. Copy the folder, paste it in your working directory. Start Visual Studio Code, open SQL, OpenGL, OpenCL from folder 110. Click this button, complex.cu. Hit enter. Also open TalkPlayFun CUDA extension.hpp. Ctrl V. I will arrange side by side. To use CUDA complex number, we need to include thrust complex H. Here, include quote, period, slash, Ctrl Z, slash, include, slash, TalkPlayFun CUDA extensions, namespace, TCE, TalkPlayFun CUDA extensions, TalkPlayFun, SStream, print, auto, endl, TalkPlayFun, endl. Void test, thrust, complex. Int main, copy this, paste it here, thrust, complex, TC1, 1.5, 3.2. We initialized complex number for CUDA Toolkit. Print TC1 equals, I will open parentheses, T underscore C1 real, T underscore C1 imaginary. I change it like this. Now open your command prompt, nvcc std c++17 on.exe extended lambda complex.cu. Hit enter. Lambda. I fixed the typo. You should be able to build successfully. The result is displayed properly like this. But this is very tedious, so we will overload a function here right before end of namespace TalkPlayFun output here template type name element type string L value reference operator string L value reference OS thrust complex element type constant L value reference C OS open curly brace C real comma C imaginary return OS. With this we can do like this: print T C1 T C1 and there. Now we build again CLS N. I missed closing parentheses here, closing parentheses. I build again CLS N. Now it works perfectly. I will copy this string, copy, and paste it here for your reference. Also this link. Now we can close this file. Control click. From this page you can refer to thrust complex class. If you scroll down you can find this link. We will refer to this source code in near future. Before doing that, we will test a few more examples. For example, STD complex C1. Let's try initialize with T1. We are consuming thrust complex to initialize STD complex. Print C1 C1 and there. Or we can also try thrust complex T C1. We are consuming STD complex to initialize thrust complex. I will copy this, paste it here, T, D, T, D. Now we rebuild CLS N. Something wrong. This is absolutely wrong. I will address this issue. Open CUDA extensions. Here in the namespace CUDA extensions template type name element type thrust complex element type cast complex STD complex element type constant L value C return C real C imaginary. I will make it inline function. Copy, paste. Now STD complex thrust complex. Control home here. Control B. I will copy this. Copy, paste. I will rename fixed. Copy this. Paste it here. I will disable it. Now I will delete this part Here PCE cast complex. I will fix like this. Here also PCE cast complex. I fixed like this. Now we rebuild CLS N. Now it works perfectly. By introducing cast complex defined here, we fixed ugly problem as is shown here. In my next episode, I will discuss partial derivative. Then we will learn how to differentiate functions over complex numbers.